Hello there. This video will show you how to do everything that you need in Excel to answer all of the questions in your second Excel lab assignment. Now, before you can do anything in Excel, you need to make sure that you have the Data Analysis Tool Pack installed in your Excel program. So I'll show you how to get that installed. I already have it, but chances are when you click the Data tab, you don't see this Data Analysis option. So if that's the case, follow these steps to get it. Click on the File tab, go down to Options, then click Add-ins, select Analysis Tool Pack, then click Go, then click OK. And then you should have the Data Analysis Tool Pack available up here once you click the Data tab. Okay, back to the assignment. So here you will see that we're looking at the same data that you looked at in the first Excel assignment, where we had GPA measured among 30 NSC, non-traditional NSC students, and then we gave them a time management workshop, and we measured their GPA afterwards. So in the first lab assignment, the first Excel assignment, you just kind of looked at the difference between the means and said, hey, GPA looks like it's better. So now I'm going to show you in this assignment how to actually do a significance test for that using the related samples t-test, or specifically the repeated measures version of the related samples t-test. And I'm also going to show you how to do a t-test for a single sample versus the population, where we're going to see if this original sample data that he collected, the GPAs from those 30 students before they received the time management workshop, if that sample was representative of the population. So let's do that first. So we want to see if our sample of students in the fall, if their GPA was representative of the population of non-traditional students at NSC. Because we want to make sure that it was representative so that we're confident that when we look at the results for after the time management workshop, that they would be relevant to the population because we represented them well with the sample. So I'll show you how to do that in Excel. Keep in mind, our population mean is 3.0. So let's go ahead and copy our data and paste it into Excel. So left click at the top left of the data that you see on that four-cornered arrow, hit Control C to copy it, then go to Excel Workbook, Control V when your cursor is selected the top left corner, and there's your data. Now, Microsoft Excel doesn't actually have a single sample t-test option, but we are going to trick it into doing it for us. So create a new variable in here called population. And let's just give population 3s throughout. So hit the 3, maybe do 2 3s. Then you can click on one of the cells with the 3 in it, go to the bottom right corner where you see that black plus sign, click and drag it down, and it magically fills in all those 3s for the population. So now we're going to click on the Data Analysis tool under the Data tab, go to t-test to sample assuming unequal variances. I'll talk about the difference between these two when we do the t-test for independent samples in Chapter 10, but for now, don't worry about it. Just know that when you're trying to trick Excel into doing a t-test for single samples, use the assuming unequal variance option. Click OK. Variable 1, let's go ahead and select the fall GPA. So left click, starting at the label fall GPA, drag all the way down to the last data point. Then click in the box that says variable 2 range and do the same thing in the population. Make sure that you check the box next to labels so Excel knows that the first value in your column is a label for that data. And let's go ahead and make this create a new worksheet. So make sure new worksheet is selected and then type in single sample T and then click OK. Before I do anything, I'm going to go ahead and have Excel convert these values into rounding to the thousandths place. So highlight all those values, right click, format cells, go to number, and 3 decimal places. and then click OK. Now, as you can see, some of this is cut off, so I want to make sure that this is sized appropriately so that everything is displayed. So if you go up to the space between column A and column B and see that double-sided arrow, double click. Do the same thing between B and C and D. It auto sizes all of those columns so that it fits everything within it. Then you want to left click and highlight the entire table. This is also referred to as an output. Hit Control C to copy. You'll see the happy dancing line saying, hey, you copied this. And then you're going to paste it into your assignment. Control V. Okay, so let me walk you through the important pieces of information that are in this output. Well, first of all, the mean for fall was 3.117. You might remember that from your first assignment where you calculated the mean for the fall GPA. And the population mean is 3, which is great because we told it to be 3 based on what we knew the population mean was. Then let's move on to the t-stat. So the t-stat is 1.080, and this t-stat is akin to the t-observed. So the t-statistic, if you were doing this by hand, that you would have calculated in step 3. And as always, this tells you that the observed difference in GPA between the sample and the population is 1.08 times larger than you would expect to see just due to chance. So that's not that impressive. It's not that much more of a difference than we would expect to see randomly due to chance. So at this point, I'm feeling pretty confident that my sample does represent my population. Any differences are probably random and not because I took a systematically different sample. Now, there's 2 different p-values, 2 different t-crits. The p-value tells you the probability of type 1 error, or in other words, the probability of randomly selecting a sample of 30 students with this mean of 3.117 from the population just due to chance. But the p-value that we want to interpret depends on whether or not it's a 1 or 2-tailed test, just like when we did this by hand in step 2. However, when we were doing this by hand and we were finding critical values in step 2, we were just using a rough estimate of the cutoff. We really didn't know how likely it was that we would get this sample mean randomly just due to chance. Or in other words, we didn't know how likely type 1 error actually was. We just knew that it was less than the alpha level. So remember, here's your alpha level for this. If your alpha level is 0.05, then that means we're willing to accept a 5% chance of type 1 error. Or in other words, the sample mean has to fall in the extreme 5% of the sampling distribution for us to be confident that it is actually significantly different from the population mean, and it's not just different because of random chance, but it's different due to something that we did to the sample. Or in other words, again, there needs to be a 5% chance or less, 5% based on the alpha level, of randomly selecting a sample mean that looks like this, the mean that we got for the sample, from 30 people from that population. Well, let's go ahead and decide if this is a 1 or 2-tailed test before we start really looking at the p-value and the t-crit. So we are wanting to see if there is a significant difference between the fall GPA for the sample and the population. Significant difference is the key word there. We're not specifying if we think that the sample is going to have a higher or a lower GPA, just that it's going to be different to see if it's different than the population. So we are doing the 2-tailed test. All right, let's look at the p-value for the 2-tailed test. So this says that the probability, well, let's go ahead and turn it into percent chance. Multiply this by 100, 28.9. There's a 28.9% chance that the difference in GPA between the sample and the population is just due to random error. Well, compared to a 5% chance, that's pretty high. So it's a little too likely that this population and sample mean are different just due to chance for us to really think that this sample does not represent the population. So this is larger than our alpha level of 0.05. So another way to think about this is the probability of type 1 error, meaning that any difference between the sample mean and population mean is just random, is 28.9%. Another way to think about it is that this sample mean falls into the extreme 28.9% of the distribution. So it's not extreme enough for us to conclude that there is a significant difference between the sample and the population. So a quick way to remember how to determine significance based on the p-value is if the p is low, reject the HO. And the HO is always going to say that there's no difference between the sample and the population in a single sample t-test. Even though technically we're kind of hoping that the null is supported because we're hoping that our sample is representative of the population, and typically our null hypothesis goes against what we expect. In this case, we expect or hope that there isn't a significant difference and that the null is true. The only reason that the null is usually representative of the opposite of what we expect is because we usually expect some sort of difference. But here, that's not so much the case. So if the p is low, reject the HO. In other words, if the p-value is less than the alpha level, then you reject the null hypothesis and conclude that there is no significant difference or significant whatever you are looking for. Think about it. This sample mean does not fall in an extreme enough part of the distribution for us to consider it to be substantially or significantly different from the population. You can also make this conclusion by comparing the observed t-value, t-stat, to the critical value. If the critical value is 2.045, well, think about it. If you draw it out, this t-stat would have to fall outside of that in the distribution, and it doesn't. It's smaller than that. So both of these will tell you that we would fail to reject the null hypothesis and say that the sample is probably representative of the population. It's not significantly different from the population. So that gets at all of this information that's right here. And then when you go to write the conclusion of the t-test in APA style, you can use your textbook as a reference for that. I have page numbers for both editions. Make sure that you italicize the notation for any kind of statistic. And make sure, so like the M and SD, where you report the mean and standard deviation, also italicize the T and the P and the R squared when you report those measures of effect size. You'll also need to report R squared based on the information that's given to you here. All you need is your t-stat and your degrees of freedom. Plug those into in the appropriate way into the formula and you can get R squared. And real quick, let me show you how to write R squared here. So you can do R, click here, see that little superscript? Click it, make sure you're under the Home tab, and then 2 for R squared. And of course, you want to make sure that that's italicized in your write-up. Another thing I want to note about APA style is that, as you'll see in the example in the book, you want to report the mean and the standard deviation for your sample. And you don't have the standard deviation given to you here, but if you remember, the standard deviation is just the square root of the variance. So if you take the variance and square that, that'll give you the standard deviation. And that's what you want to report when you're reporting this in APA style. Okay. Related samples t-test. So now we're going to see if there's a significant improvement, significantly higher GPA in the spring after they took the time management workshop. So we know it's higher, but is it significantly higher? Is it higher than we would expect to see just randomly due to sampling error? So let's go ahead and do that in Excel. Okay. Let's go back to the data, Go up to the Data tab, select Data Analysis, and now let's select t-test paired to sample for means. Click OK. Now for variable 1, let's go ahead and select spring GPA. And then for variable 2, let's select fall GPA. Keep your alpha at 0.05, make sure labels is selected, and then let's put this in a new worksheet called T-related. And then click OK. Once again, let's go ahead and convert these values so that they are rounded to the thousands place. So just click and highlight it, go to Format Cells, select Number, 3 decimal places, click OK. Then do the double click in between all the columns so that it auto-fits. Click and highlight, Control C, copy this, and let's go ahead and paste this into our Excel assignment using the Control V command. Okay, so now let's look at this. The mean for spring was 3.437, which is in fact higher than the mean for fall. Here are your variances for spring and fall, which you are going to need for your conclusion in APA style for number 12. Don't worry about the correlation. The number of observations, there's 30 people. And degrees of freedom, n minus 1, 30 minus 1 is 29. So here is your T statistic. This is 4.85. So that would be what you would have calculated in step 3 if you were doing this by hand. Now what this tells you is that the difference between spring and fall GPA is 4.85 times larger than the difference expected just due to random chance, even if the time management workshop had no effect on GPA whatsoever. That's pretty impressive. That's a pretty big difference. So right now I'm feeling pretty confident that it is the time management workshop that actually resulted in this change in GPA. Now this is a one-tailed test because we think that the GPA will be significantly higher in the spring. So we want to only look at the P value and the T critical for the one-tailed test. This P value is saying there's essentially very, 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 very low likelihood that the observed difference between the spring GPA and the fall GPA is just due to random chance differences and not due to the time management workshop. Keep in mind, though, that if we didn't round this to the thousands place, there's no way that you're going to have an absolute no chance, 0.00000% chance. But because we rounded, it just goes out to the 0. So when you report this in your conclusion in APA style, you'll want to write P is less than 0.001, not P equals 0.000, just to show that you realize there's some chance of type 1 error, but it's really, really low. Then this T critical right here is 1.699. And this certainly exceeds that in the high end of the distribution, because we're looking at a one-tailed test in the high end. So both of these things tell you to reject the null hypothesis and say there is a significant improvement in GPAs in the spring, or that the GPA for spring is significantly higher than the fall. Remember, if the P is low, reject the HO. Or in other words, if the P value is less than the alpha level, then there is a significant finding. And then the T critical and the T observed, or T stat in this case, you've known how to compare those two for a while. Now, when it comes to writing the conclusion of the t-test in APA style, just make sure that you italicize all the notation for your t-tests, and I want you to calculate your standard deviations by taking the square roots of your variance and finding the difference between those two standard deviations. That's what you can report in your conclusion, where it says, after implementing the time management workshop, you can say the GPA increased by an average of M equals, so the difference between these two, points with the standard deviation, or with SD, as you'll see in the book, equals whatever the difference between these two standard deviations are. Remember, you have to take the square root of the variance, find the standard deviation. And then you can just talk about how the treatment effect was statistically significant and report your test statistics as you see reported in the book, making sure that you put p less than 0.001 for the reasons that I mentioned before. Also, you need to calculate your R squared, which you'll know how to do based on your t-stat and degrees of freedom, and you can use the notation that I showed you how to get earlier. So I hope that you found this video very useful and it shows you how to use Excel for the things that we've been doing by hand in class. And happy computing!